বৃষ্টি করে
Itu yang use karena apa? Apa tuh lo bandang upload ya? Iya, awal dari. Jadi kena. Bisa use no that. No.
Okay, let us start the class. Oh. In our last class, we discussed about the design of how we can do the design of a boost converter. And in section A, I think apart from section A, in section B and section C, we discussed about the relationship between the output and the input of a buck boost converter, right? I haven't started a buck boost converter for section A, right?
Yes, sir. Yes, sir.
So today I will start from the buck boost converter, and then I will try to finish the choke converter as well. in today's class. So if you remember, just to recap the things, so if I want to have a buck boost converter, so for buck boost converter, actually what is happening here, the inductor is the inductor is actually storing the energy, and it will release the energy to the load, and the capacitor in the circuit, they are actually uh, just there to maintain a constant voltage. So if you remember, the buck converter was like this. So you had a source, and then you had a switch, then you had an inductor which was connected with a diode, and then we had a capacitor, and we had a load here. So that was my buck converter. So in buck converter, this inductance L was responsible for storing energy and provided that energy to the output. And the capacitor used here, its responsibility was to just keep the output voltage always constant with minimum number of minimum ripple available for the circuit. And one of the thing that we need to understand here, for the buck converter, the inductor is directly connected to the output side, or it is connected to the load. Now, what we can do, if I change while starting with the boost converter, we say that if we change or switch the position of the our resistance or the load with the source voltage, the thing will work as a boost converter. So what we did.
The oil source could be more.
Is there any question? So instead of connecting this inductor with the load, if we connect the inductor with the source, and then it is connected to a switch. Suppose this is my T1, this is D1. So if we connect that with the source voltage, with a diode, and then we have a capacitor and load, then again in this circuit, this inductor is actually responsible for storing energy and providing that energy later to the load or the output. And the capacitor we used here, it is responsible for keeping the output voltage constant with minimum ripple in the circuit, output voltage or in the circuit. So this is my boost converter. So for the buck boost converter, what we can do, since for buck operation, we need to connect the inductor with the load, and for boost conversion, we need the inductor to connect it to the source. So what we can do, if we keep the voltage source, and if we keep the capacitor with the load, and if we keep this inductor in such a way that, suppose it's a double pole switch. So for double pole switch, the inductor, it will be connected to A terminal for D multiplied by Ts time, and then it will be connected to the B terminal for 1 minus D multiplied by Ts time. So when the inductor will be connected to the source circuit, then what will happen? it will act like a boost converter. And then when it will be connected to the load, then it will act as a buck converter, right? So in a way, by configuring the inductor position, we can make the circuit operate like a buck boost converter. So what we can do here then instead of using this double pole switch, we'll use a semiconductor switch for the circuit. So what we can do instead of this circuit, we can have a buck boost converter using two switch. So one switch would be my transistor, then it will be connected to that inductor, and then we'll have a diode placed as another switch, and then it will be connected to the capacitor, which will in turn will be connected to the load circuit. So instead of having this polarity plus minus in this direction, what we can do here, we will choose the polarity in the reverse direction, because basically what we'll see that the polarity will be reversed. So for the buck boost converter or the choke converter, actually the polarities will be reversed of the source voltage. So we'll keep that polarity in this direction like this. So this is my V naught output. This is my R. This is C. This is D1. This is my L. And this circuit will be operated as a buck boost converter. Is there any question so far?
নিচের জায়গায় সব ট্রানজিস্টর ইউজ করে স্যার
I didn't hear you clearly. Can anyone explain what he asked?
স্যার মানে স্যার যে ট্রানজিস্টর এর পার্টটা স্যার যে এই সার্কিট থেকে নেক্সট সার্কিট এই যে ট্রানজিস্টরটা যে আছে স্যার এই ব্যাপারটা একটু ক্লিয়ার করলে
What's about the position of the transistor?
The question was about how did you replace the switches with the transistor and diodes.
Because the double pole throw switch, it's a mechanical switch, right? So we cannot have a double pole switch here. Instead of that, we have to use two semiconductor switches there. That's why we choose that transistor and the diode, because transistor is a voltage control voltage source, right? So if we put voltage at the base, we can make the transistor on and off. But the diode, is it a control device or uncontrolled device?
uncontrolled. Uncontrolled.
Right. So you need to have a control over one switch so that you can make the switch on for a certain period of time, because here you can see the switch needs to be connected at a point during a certain time interval, right? So by using this transistor, we will make sure that this inductor will be connected to the source for the duration of time we want it. That's why we use a transistor switch there. And as the point is connected there, so the inductor current will be in this direction, right? Because the current, it will come from the source. But when this point is connected here in the B point, then what will happen? Suppose you don't have this thing connected anymore. So what will happen? The transistor current will try to go through this point to the capacitor and the load, and then it will try to come back through the inductor, right?
Sir.
So in order to incorporate that one, we used the diode in this direction, so that whenever your switch is this transistor is on, it will make this thing, this diode in reverse bias, so that the source current will only follow through the inductor. In other words, we can say the source will charge up the inductor so that the inductor can store the energy. And then when the switch is off, then whatever energy the inductor is gathered when the switch was on, it can release through the capacitor and the load. Do you understand what I have taught so far?
Yes, sir.
Any more question?
So why do we choose the V output reverse as compared to the buck converter or boost converter?
Because if you choose the direction of the converter in this direction, we will finally see that your output voltage will be negative. So in a few moments we will derive that your output voltage will be minus of D over 1 minus D multiplied by Vs. So there will be a negative sign in front of the output voltage, so that if you choose the voltage polarity is like this, it will mean that your output would be opposite of the polarity chosen. That's why in order to avoid this minus sign here, we are keeping this voltage polarities like this. Okay.
Okay, sir.
Any more question? Okay. So now let us try to draw the waveform. So suppose for the first time, I will try to draw the uh, switch waveform. Suppose this is my VT1. So VT1 is basically the voltage between base and the emitter. So if I say this is my VT1, so suppose this is on for certain period, and then it is off for a certain period. Again, it is on for a certain period and it is off for a certain period. So this is basically my D multiplied by TS. And then this portion from this to this, we are considering this is 1 minus D multiplied by TS. So we'll be putting a voltage between the base to emitter during this time. And similar way, we will put another voltage during this to this time. So actually, whenever we are putting a pulses, that transistor T1 will turn on, and when there will be no pulses, the transistor will be turned off. So here, as you can see, there will be two mode of operation. So for mode 1, actually, we are putting pulses at the base of the transistor T1. So transistor T1 will be on for D multiplied by Ts time. And as the transistor turned on, then the circuit will look like. So these 2 points will be operating like a short circuit. And then you will have a inductor. Yeah. The diode here, it will be like this, which will be connected to the load. So this is negative, this is positive, this is my V naught. So as you can see, the negative polarities of the output, it will be connected to the anode of the diode. So what will happen here? The current, this diode will be turned off. So what we can see here, so instead of this switch, we can keep this terminal. I am hearing some echo.
wants a different kind of potato. So I'm making different kinds of potatoes. See, here's what kind of potatoes.
Now, if I want to, this will be my IL. This is my L. This is C and R. So what will be the voltage across the inductor? So the voltage across inductor would be the source voltage, right? So we can write VL, it would be my VS, or we can write L multiplied by del IL over, we can say del IL1 over D multiplied by TS, it should be equals to VS. So that gives you del IL1, it should be VS over L multiplied by D into TS. That would is your equation number 1. And here also, since this inter-source is in series, so we can say my IS, it would be equals to my IL. And since we are considering the output polarities like this, so we can consider this is my I naught and this is my IC. So what should be the relationship if I put a KCL at this point? So what do I will get? My IC plus I naught, it would be equals to 0. So that gives me IC, it would be equals to minus I naught. Is there any question regarding these equations? Any question?
Sir, I think these were covered in the class.
Yeah, because I didn't cover it for section A, so I am just going through from the first. Okay, so just
Oh,
bear patience for 5 to 10 minutes. Okay, and then we'll cover the new thing. Okay.
okay, sir.
So now, if I draw the output voltage VL, what is the VL during that time when that transistor was turned on? It should be the source voltage, right? So I will get the VL will be exact same as the source voltage Vs. And then if I want to draw the current, so suppose I want to draw the current, this is my IL. So I choose two extreme points here. So current will ramp on from one point to another. Why is that? Because this thing, is it positive or negative? Is it positive or negative?
Positive.
Positive. So current will have a positive slope. So this slope should be Vs over L, right? And okay, so rest of the thing I will try to draw that later for the capacitor current. So for the capacitor current, what will happen? So here, if I want to draw the source current, suppose this is my source current, IS. Okay, let me draw it a little bit below. So let me, okay, so we can draw it here also. Okay, so this is my, suppose IS. So what is the relationship between IS and IL? It will be exactly the same thing as your IS, right? IS and IL would be the same thing, right? So it will be same as your IL. And what should be your capacitor current? IC is minus of I naught. Minus of I naught means if this is my IC, so I naught is constant, that is my V naught over R. So here for IC, we will get a constant current. This will be my constant current. And that should be my minus I naught, which is minus V naught over R. Is there any question regarding this waveform? Any question? Okay. So now, if I want to get the relationship for mode 2, what we can get? So for mode 2, T1 will be turned off for 1 minus D multiplied by Ts time. So if it is turned off for 1 minus D multiplied by Ts time, so what will be my equivalent circuit look like? So this should be my source Vs. And now this switch is turned off. T1 is turned off, so it will act like a open circuit. Then we'll have a inductor. Then we have a diode. And then we have a capacitor. And then we have output voltage V naught. Sorry, V naught polarity we choose in the opposite direction. So previously the inductor current was in this direction IL. So the inductor current will try to maintain its direction in the same way. So in that inductor current will go like this. So this should be my capacitor current and this should be my output load current, and it will come back through this diode like this. So in this case, the inductor current will force the diode to turn on. So what we can write here, instead of diode, we can choose, since the diode is operating, we can choose the diode like a short circuit path. Any question? And previously the inductor polarity, we considered that in that way. So now, can anyone tell me what should be the voltage across the inductor?
Minus V naught.
This is, so if I take a Kirchhoff's voltage law here, this should be also my V naught. So if I take a Kirchhoff's voltage law, what we can write? Minus VL minus V naught, that should be equals to 0. So it gives me VL, it should be equals to minus V naught. So we can write L multiplied by del IL2 over 1 minus D multiplied by Ts, that should be equals to my minus V naught, or we can say del IL2, it should be my minus V naught over L multiplied by 1 minus D multiplied by Ts. That should be my equation number 2. So now, since this slope is negative, so what will happen to the inductor current? So the voltage across the inductor, we can write, this should be my negative voltage. This should be my V naught. So it will continue like this. I will have positive voltage and then I will have a negative voltage like this. The top voltage will be Vs and the bottom voltage it would be your V naught. And since the current slope is negative, so what will happen to the inductor current? So it will discharge from this point, right? Like this. And again, in the this sequence will repeat. Right? Any question regarding this waveform? Inductor voltage and inductor current.
Sir, I couldn't hear the last thing you said. Can you repeat it again?
I said the inductor current change, it has a negative slope, right?
Yes, sir.
So whenever you have a negative slope, what does it mean? It will have a negative slope, mean the previous point will be at higher value with respect to the next point, right?
Yes, sir.
Is that your question or you asked anything else?
Sir, it was my question.
Okay. So now for mode 2, what will be my source current? What will be my source current?
Zero. Zero.
So in that case, my source current, it should be 0, right? So meaning that when the inductor is discharging, my source current, it should be 0, right? And then again, it will start like this. And during the discharging period, it should be 0, right? So this should be my current for the source. Make sense? Any question regarding that? Okay. Then if I use KCL at this point, KCL, so what does it say? My IL, it should be equals to IC plus I naught, right? So my IC, it should be equals to what? IL minus I naught, right? So now let's see what should be the relationship between your IL and I naught later. But before that, we'll try to do the voltage second balance. So what does the voltage second balance says? What does the voltage second balance says? So if I integrate the area for voltage across the inductor V lambda d lambda over switching period, that should give you 0, right? So what was the voltage across the inductor during D multiplied by Ts time Vs, right? So that says that Vs multiplied by D into Ts. And what is the voltage across the inductor when the transistor was off? Minus V naught, right? So minus V naught multiplied by 1 minus D multiplied by Ts, that should be equals to 0, right? So that gives me Vs multiplied by D into Ts minus equals to V naught 1 minus D multiplied by Ts. So if we cancel Ts, so we can write your V naught is nothing but D over 1 minus D multiplied by Vs. So the relationship between your output and input is governed by D over 1 minus D. So what will happen if we change the value of D? So suppose your D is D is 0. So what will happen? So what will happen?
Output voltage will be zero.
Your
Output voltage will be zero.
Zero, right? Okay. Now, if I consider D is 0.5, then what will happen? 0.5 over 1 minus 0.5.
The
So
output
0.5
voltage
over
equal to source
0.5.
voltage.
So your output, it should be equals to your source voltage, right? So now, if I make less than 0.5, suppose 0.25, then what will be the relationship between output and input? So if D is 0.25, then 1 minus 0.25 would be 0.75, right? So 0.25 over 0.75, it should be 1 over 3. So your V naught will be less than your source voltage, right?
Yes, sir.
So it will be operated as a buck converter. If your D is more than 0.5, then what will happen?
V not greater than 0.
So here we can write like this. So if your D is greater than 0 but less than 0.5, then it will work like a buck converter. And if it is greater than 0.5 but less than 1, then what will happen? Suppose we are considering D to be 0.75. So 0.75 over 1 minus 0.75. So it will give you 0.75 over 0.25. So your output will be 3 times higher than your source voltage. So in that case, your V naught will be higher than Vs. So it will operate like a boost converter, right? So by choosing the appropriate value of D, we can make this circuit operate in either way. It can be operated as a buck converter or it can be operated as a boost converter. Is there any question so far? Any question? Okay. So now, if I got this point, so basically in the last class also we said DC to DC converter, it's basically it's a DC transformer, right? Because if you put Vs input, that should be my Is, and if you put V output V naught, and if it is my output I0, as you can see here, everything in between the source and the load, there is there any lossy component in between?
Yes, sir.
So it means whatever power you are dumping into the system, the load will consume that one, right? So what we can say here is your VSIS, it should be equals to V naught I naught, right? Now what we can write here is that, so V naught I naught, if I push it here, so what is Vs? From this equation, what we can write, 1 minus D over D multiplied by V naught, right? So we can write 1 minus D over D multiplied by V naught, and then we have Is, right? If we cancel this out, V naught, what is the relationship between output current and input current? source current 1 minus D over D multiplied by IS. So that is the relationship between your output current and input source current. So now, what is the relationship between your output current and the inductor current? Inductor current, should the inductor current be same as the output current? What we can see from here, is the inductor current is same as the output current? Sorry, input current or the source current?
Yes, sir.
Is it the same?
For mode 1 same. For mode 1 same, mode 2 তে দিব।
It is same for mode 1, right? So suppose this is my average inductor current. This is my I average, IL. And this is also my average inductor current, like this. This is my IL average. Sorry, IL. So previously we said that this is my IL max. This is my IL mean. And what is the difference between these two extreme points? We call it as del IL, right?
Yes, sir.
Right?
Yes,
So
sir.
now, if I want to get the relationship between the inductor current and the input current, so what we can get, now if I want to get the area of this triangle, suppose if we want to get the area of this triangle 0, A, B, C. So what should be the area of this triangle? The area under 0, A, B, C. So it should be this area.
So integral of
So if you try to do the integration, that will be tricky, right?
So, but is it,
দুই ভাগ করে বের করলে
is it a triangle?
We can do two, right? Suppose the triangle like this, and we have.
Yeah.
So what should be the area of
Into some rest times height.
del IL.
TTS
So
and
area of the triangle, it should be half multiplied by this area, right? This length is what? D multiplied by TS, right?
Yes, sir.
And what is the length of this area?
del IL.
Is same as del IL, right?
Yes, sir.
Right?
Yes, sir.
So this should be my del IL. Plus, what should be the area? This
IL mean into DTS.
right. So it should be IL mean multiplied by D into TS. So what is IL mean? Again, so half multiplied by D into TS multiplied by del IL, then plus IL mean is what? IL minus half into del IL, right? That should be your IL mean, right? We have used that equation several times, right?
Yes, sir.
So multiplied by DTS. So what should be the area? Then, so here you have half multiplied by d into ts multiplied by del IL, then plus IL minus half into del IL multiplied by d into ts. So what I should get? Sorry, I made one mistake here. So it should be IL multiplied by d into ts, right? So here it should be IL multiplied by d into ts, right? So this should be the area 0. So the total area under this curve is 0 A B C. It should be what? IL multiplied by d into ts, right? Right?
Yes, sir.
So what should be the average current, IS? What should be the average current? Average IS, it should be 1 over T multiplied by IS dt, right? Over the time T. Or we can write as 1 over Ts, that should be Ts, right? So this is the integration. This area that I get is what? 1 over T, then the area 0 A B C is what? IL multiplied by D into TS. And the area from here to here, it is 0, right? So what should be the into TS? So if I cancel this out, so average source current, it should be what? D multiplied by IL. Does that make sense?
Yes, sir.
So then your IS is D multiplied by IL. So now if I put this value here, so we can write your I naught is 1 minus D over D multiplied by IS. So IS is what? D multiplied by IL, right? So what is your IL? IL should be 1 over 1 minus D multiplied by I naught. Is there any confusion regarding the output current and the inductor current? Any confusion?
No, sir.
So here we can write also. So if my D is greater than 0 but less than 1, you will find that your IL is always greater than what? I naught, right?
Greater than 0.0 না কি বললেন?
What is your operating point of D? It should be greater than 0 but less than 1, right?
Yes, sir.
So for that, any value in between that range, you will find that your IL is greater than I naught, right? If you get your IL is greater than I naught, so here we had this relationship IC for mode 2. IC is IL minus I naught. So your IC was IL minus I naught. So what was my IL? My IL was combination of two things. One is the average IL and a triangular wave superimposed on IL, right? So it should be what? For IL, we can say it should be IL plus del IL triangular. And what is my I naught? I naught is a constant value. So what we can say, it should be, so here, when you have this point, so this is my IL max, right? So what should be the capacitor current at this point? So for the inductor current, this point is your IL max, meaning this point should be IL max when it will start discharging. So what should be your IC value? It should be IL max minus I naught, right? Meaning that your capacitor current here will have a value. This value should be IL max minus I naught. It will start from here and discharge like this. So this point also, it will be IL mean minus I naught. And this capacitor current will be like this for the rest of the circuit. Any question regarding this? Any question?
স্যার ক্যাপাসিটর কারেন্টের পার্টটা একটু শর্ট করে বুঝাই দিলে ভালো হয়, অল্প করে।
This point is what? IL max, right? When the
Yes, sir.
transistor T1 is turned off. So the moment transistor is turned off, what was the inductor current? It was IL max, right?
Yes, sir.
And it says the capacitor current when the transistor is turned off, it should be IL minus I naught, right?
Yes, sir.
So what was IL value when the transistor is turned off?
IL max.
IL max, right?
Yes, sir.
So what should be the starting point for the capacitor current?
Oh, yeah, okay, sir. বুঝতে পারছি।
So the starting point for the capacitor current, it should be IL max minus I naught, right?
Yes, sir.
Which is this point, right? And again, the difference peak to peak value between for the IC, it should be IL minus I naught, and here it should be minus I naught. So the total difference, it should be what? IL
Max.
max, right?
Yes, sir.
Any question? Any question? Okay, so now for IL, if I want to rewrite this thing, so what we can write, 1 minus D, what is my I naught? It should be V naught over R, right? So instead of V naught, what we can write, what is the relationship between V naught and Vs? So we can write, it should be D over 1 minus D whole square multiplied by R multiplied by Vs. If I put, instead of V naught, if we put the value of this equation into this equation, we'll get this result, right? Right?
Yes, sir.
So now, if I get the inductor value, inductor current, average inductor current, which will be D over 1 minus D whole square multiplied by R into Vs. So what would be my IL max then? IL max, it should be IL plus half into del IL, right? So during this charging period, what was my del IL? During this charging period, what was my del IL? It was Vs over L multiplied by D into Ts, right? So here we can write, what is my IL? It should be D over 1 minus D whole square multiplied by R. And then, okay, so here we should have Vs also here. And then half, and it should be Vs over L multiplied by D into Ts. So here in both term, we have D into Vs. So if I take D into Vs common, so we can write 1 over 1 minus D whole square multiplied by R plus half to L. Instead of Ts, we can write it as Fs, right? Right? So what
Yes.
would be my minimum value then? Minimum value should be IL minus half of del IL. So it should be again D multiplied by Vs 1 over 1 minus D whole square multiplied by R minus 1 over twice L Fs. So in the last class also, in the previous couple of classes, we said that if you reduce the inductor value, what will happen? The current will try to go down, right? And then we'll have a position like this. Position like this, for which we'll get a current like this. It will start from 0 and it will go to touch 0. And then again, it will start from 0 and then it will go to 0. So that should be the extreme point for the continuous current, right? And in order to obtain that thing, what we can do, we have done this for several times, right? Then what should be the minimum value of inductance?
0. IL means equals
So for that one, we can write IL mean that should be equals to 0, meaning your D multiplied by Vs over 1 minus D whole square multiplied by R minus 1 over twice LFS. That should be equals to 0. So this thing cannot be 0. So this thing has to be 0. So we can write 1 over 1 minus D whole square multiplied by R. That should be equals to, here we can call mean. So 2L mean multiplied by Fs. So what should be the L mean value then? So L mean, it should be equals to what? 1 minus D whole square multiplied by R over 2 into Fs. That should be the equation for L mean. Now, you have to make sure that your L that is chosen for the circuit, it should be greater than your L mean, so that the circuit will be always operating in the continuous current mode. Right? And
Yes.
again, if I want to get the value of the capacitance, in the previous class also, we said that C multiplied by del B, that should be equals to del Q, right? So what is del Q? The area of the curve for the capacitor current, right? So what should be the area of this capacitor current? Because your Q is nothing but integration of IC dt, right? So what should be the area? What should be the area?
Minus I naught TTS.
Okay, so if I take the magnitude, it should be V naught over R, that should be minus I naught. So we can call it V naught. V naught over R multiplied by D into TS, right? That should be the area for the angle, because this area, this time is D multiplied by TS, and this magnitude, this is nothing but your I naught, which is again V naught over R. So V naught over R multiplied by D into TS, that gives you the change in charge. So from that one, what we can write, your C, it should be V naught over del V naught multiplied by R into D over, instead of T, we can write it as Fs. So that should be the equation for your capacitor currents. And we have said so many times that if you want to reduce the ripple, you have to choose capacitor should have a higher value, right? So this capacitor in the buck boost converter, what they are doing, the capacitor here, the buck boost converter, or the simple buck or boost converter, is that the capacitor actually keeping the output voltage always constant with minimum ripple. But the actual energy storage and the power which is supplied to the load, it is done by this inductor, right? So is there any question regarding this buck boost converter?
Sir, I have a question.
Yeah, sure.
Sir, for the equation of del IL, in the buck converter, we choose equation 2. The inductor current is ramping down. For the boost converter, we have choose equation 1. And for this buck boost converter, we have choose equation 1. For the buck converter, we have choose equation 2 because the inductor was in the load side.
Right.
For the boost converter, the inductor was in the source side. But in the case of buck boost converter, why we have choose equation 1?
Buck boost converter, we choose the equation 1 because, as you can see here, the inductor current, actually your source current here, your source current is directly related to the inductor current, right?
Yes, sir.
Right?
Yes, sir.
Meaning the source output is dependent on what? Inductor charging, right?
Yes, sir.
Meaning that we choose mode 1 because this is the time when the source is providing power to the inductor, which is later going to the output, right?
Yes, sir.
So that's why we choose the first portion, because this is the thing that is responsible for providing power to the output.
Okay, sir. I have understood.
Make sense? Is there any other question?
Yes, sir. Sir,
Yes.
how we found out the average value of the inductor current? Can you repeat?
Yeah, so the average current of the inductor, it is like this. So suppose your source current is like that. So this is your source current. I am just redrawing the source current. So suppose this is your source current, and it is basically the same current that the inductor has. So this is the same current that your inductor has when for D multiplied by Ts time, right? Right? Here you see the source current, it is exactly the same thing as the inductor current when the inductor is charging, right? Because the inductor current is directly coming from where? Where? The source, right?
Yes, sir.
right?
Yes, sir.
So now how can we get the average value of the source current? So average value of the source current is what? My total time period. So it suppose this is 1 minus d multiplied by ts. So that should be my total time period, right? Ts. So it should be 1 over ts, then integration of t, and then it should be is dt. So is dt means what? The area under the curve, right?
Yes, sir.
So what should be the area? So here we can divide this area by 2 amount. So this should be my I mean. This point is my I max. And the total current difference is my del IL, right?
Yes, sir.
Right?
Yes.
So 1 over Ts multiplied by the total area. So what should be the area of this curve, of this triangle? It should be half multiplied by the
D.
length. Length is what? D multiplied by Ts multiplied by this length, right? And this length is del IL plus this area. What should be the this area of this rectangle? It should be I mean multiplied by D into Ts, right?
Yes, sir.
Right?
Yes. Yes, sir.
So what I can write for I mean, we just write it down. So what is my I mean? IL over half into del IL, right? So if I put this value here, you will finally see that it should be 1 over Ts multiplied by IL into D into Ts. So if you neglect that down, cut it down, so then you will get your Is is D multiplied by IL, which we got here. Make sense?
Sir.
You know how to calculate average value of a signal, right? Do I need to clarify anything else? Anything else? Okay, then we'll start the Chuk converter today. So basically, as I said before, for the buck boost converter, actually the energy is being stored and supplied to the load by the inductor. And the capacitor at the output, which is connected to the load, it always keeps the load voltage constant with minimum ripple. But for the tube converter or the SEPIC converter, you will find that the energy is being absorbed by your capacitor. And this capacitor is not the output capacitor. We have to introduce a new capacitor in the circuit so that it can store the energy. So what is the circuit for the Chuk converter? Let me draw it first, and then I will try to explain its operation. So before I start the Chuk converter, is there any question regarding buck boost or buck boost converter? এই ক্লাস কি বোঝা যাচ্ছে না?
স্যার যাচ্ছে।
I think you have just logged in and then moved out doing other work, right? You are not listening to the class lecture. So should I close this lecture today?
No, sir. Please continue.
Okay. So for the Chuk converter, the circuit will look like this. So for the Chuk converter, we'll have two inductance and two capacitance. So suppose this is my voltage source Vs, then it is connected to a inductor, that is my inductor 1 L1. Then we have a switch. This is my switch T1. Then we have a capacitor, that is my C1. So this capacitor is a big capacitor that will store all the energy, not like the capacitor we introduced in buck boost converter for maintaining the output voltage. We'll have another capacitor at the output whose responsibility will be to make the output voltage constant. But this capacitor here, C1, it's a very big capacitor. As we will see, it will be responsible for storing energy and then provide that energy to the output. So then after this capacitor, we'll have a diode. And then we'll have another inductor. Sorry, we'll have another inductor. L2. And then we'll have a capacitor. This capacitor here, C2, it will keep the output voltage always constant, as always, like the boost and buck converter. So here also we are keeping the output voltage in these polarities, because like the buck boost converter, the Chuk converter output voltage will be in the inverting polarities. So whatever polarity is the source voltage, output will be the opposite of that one. So for the inductor, we are considering this voltage VL and current is going in this direction. That should be my IL1. For inductor 2, the current direction is in this way. So that should be my VL2, and current direction will be in this direction. That should be my IL2. And the voltage across the capacitor, it should be VC1. This is my diode D1. And this is my IC1. This is my I0. And current going through the capacitor, we are considering in this direction. This should be my IC1. So basically in steady state, what we can see here during steady state, the average voltage across the capacitor, it will be VC1. It should be equals to Vs minus V0. Can anybody say why is that? Because in previous case, we say the average voltage across the inductor, it should be equals to 0, right?
Yes, sir.
So
Yes, sir.
the average voltage here, it should be 0. The average voltage here, it should be 0. So it means that average voltage across the inductor, it should be the difference between the source voltage and the output voltage, right?
Yes, sir.
Make sense?
Yes, sir.
So now, as always, if I consider that, suppose this is my voltage waveform VT1, this is T. So Suppose we put voltage waveform like this. So T1 is on, turned on for this period, and then again it is turned off. So let me redraw this. So this time it will be turned on again, and here it will be turned off. So now this is my D multiplied by Ts, and this should be my 1 minus D multiplied by Ts. Okay, this time period. So during mode 1, what is happening? Your T1 is on for D multiplied by Ts time. So if this thing is turned on, so what will happen? The circuit will look like this. The circuit will look like this, right? This circuit, we can think of two separate circuit because this is short circuit. So we can consider this circuit to have two portions. So for the first portion, we'll have a circuit like this. Second part, the circuit will be like this, right? Two portion of the circuit. Right?
Yes, sir.
So here, as you can see, that negative terminal of the capacitor C1 is connected to the anode of the diode, and positive terminal is connected to the cathode of the diode. So the diode will be in the reverse bias position. So we can neglect this diode here because the diode will be in reverse bias. So now if I want to derive the equation for the voltage for inductor and current, then what should be the voltage across the inductor? VL1, it should be equals to VS, right? So we can write L multiplied by L1 multiplied by DL del of IL1 over D multiplied by TS, that should be equals to your VS, or we can write, it should be 1. So we can write del IL1 for inductor 1. So it should be VS over L1 multiplied by D into TS. That should be your equation number 1. And what is the relationship between your source current and the inductor current? Suppose this is my source current. So we can write your IS, it should be equals to IL, right? Right?
Yes, sir.
So now, if I want to get the relationship for VL2, so if I do the Kirchhoff's voltage law here, in the second circuit, what we can get? Plus VC1 minus VL2, then again minus V0, that should be equals to 0. So here we can write down VL2, it should be equals to VC1 minus V0, right?
Yes, sir.
And now, if I want to relate between IC and IL2, these two directions, they are different, right? So we can write IC1 is minus IL2. And then if I put KCL at this point, we can write IL2, it should be equals to IC2 plus I0. Or we can write IC2, it should be equals to IL2 minus I0. This is my relationship for what? The inductor current and the inductor voltage for two inductors, right? And
Yes, sir.
this thing, it should be equals to L2 multiplied by del IL2 over D into, 1 minus D into TS. One minus D multiplied by TS. So hence we can write your del IL2 should be equals to VC1 minus V0 over L2. That should be, and then 1 minus D multiplied by TS. So that should be your equation number 2. Now, for mode 2, so this is for mode 1, when transistor is turned on. Now for mode 2,
Sir,
yes.
sir, for mode 1, why you have write 1 minus D into TS for VL2?
Oh, sorry, I made
Shouldn't we-
mistake. Sorry,
shouldn't
sorry.
we-
Thank you so much. Right. It should be D multiplied by TS. Sorry. It should be D multiplied by TS because we are in mode 1, right? Okay. So for mode 2, what will happen? So more for mode 2, T1 is off for 1 minus D multiplied by TS time. So if this thing is off for 1 minus D multiplied by TS time, so the circuit will look like this. So suppose we'll have a source, then we have an inductor, Then we have a capacitor. Here, this switch is turned off. And then again, we have an inductor. In between, we have a diode. Then we'll have a capacitor. And then we'll have an output. So suppose this is R. This polarities is V naught. So this is your VC2 plus minus. So this is my IC2. This is my I naught. Okay, so we are considering the voltage polarity in the same way. So this should be my VL2. This is L2, which is providing current in this direction, IL2. And this is the polarities for VL1. So it is providing current IL1 in this direction. This is my L1. And this is my capacitor. So that should be your VC1. And the capacitor current is in this direction. So what will happen now? Since this inductor and this inductor both have a current direction, and the inductor doesn't like the current to change its direction, so both of them, inductor L1 and L2, will force this diode to operate so that the inductor 1 current can go through diode like this, and the current through the inductor, it can go through this diode in this direction. You understand my point, right? So the inductor current will go in this direction, and the inductor 2 current, it will force the diode to operate in this way so that current can go through in this direction. Make sense?
So could you explain it again?
Yeah, so what was the current through the inductor for mode 1? So the current through the inductor was in this direction, right? And current through the inductor 2 was in this direction, right?
Yes,
So
sir.
when the switch is turned off, that inductor, will it allow to current flow in the opposite direction, or it will try to keep the current in the same direction?
Try to keep it in the same.
Same direction.
So this current comes here and this current comes here, and then they will combine, go through this diode. So they will make sure the diode is turned on so that both inductor current can pass through this diode. Make sense?
Yes, sir.
So then what would be the circuit look like? So in a similar way, we can choose this circuit. It will have two components, like we'll have this thing, inductor, and then capacitor, which is shorted by the diode. So here we can see this diode is shorted. So that should be your plus minus L1. This should be your VL1, and current is going in the same direction, IL1. And this is your voltage VC1, and the capacitor current direction IC1. We keep that in the same direction. So that should be your circuit 1 before the diode. And after the diode, what will happen? It will have another circuit, that is this inductor. So it should be this terminal should be the positive one, and this terminal should be the negative one. And then it will be connected to the capacitor, and then it will be connected to the output. So this is V naught. This is my R. Similar way, this is my VC1. This is C. This is L. This is my VL2. This is my L2. And the current is going in this direction. This is my IL2. And we consider that this is my IC2, and this current is my I naught. Is there any confusion regarding this circuit or any kind of equation? Any question?
No, sir.
Sir,
Yes.
here shouldn't the output voltage have the same polarity as the input voltage?
Why is that? We kept the output voltage polarity is always opposite of the input voltage, right?
Yes, sir.
Because like the buck boost converter, we will find that if we keep the output voltage in this polarity, you will find that there will be a negative sign in the front of the output equation. So in order to avoid that, we are just doing this. Okay.
Thank you, sir.
So let me copy the thing. This is my PS. So now for mode 2, then what should be the equation for VL1? What should be the equation for VL1?
PS minus VC1.
Right. So it should be Vs minus Vc1, right? And it should be equals to my L1 into del IL 2 over 1 minus D multiplied by Ts. So for del IL2, we can write Vs minus
Del IL1.
Actually, you can say it as 1, 2 because it is the discharging phase of current 1, right?
Yes, sir.
So it should be, so previous case also, you can say it as L11 and here you can say it as 21. Okay, so the charging state we are considering it 1 and the discharging phase we are considering it 2. Okay.
Okay, sir.
1. So that should be equals to L1 multiplied by 1 minus D multiplied by Ts. So that should be the inductor voltage. And now, so here in the first case, what was the voltage across the inductor? 1. That was Vs, right? So if I try to draw the inductor voltage VL1, so for the first case, it should be a positive voltage, right? And that should be your Vs. But for the second case, the voltage across the inductor, it should be Vs minus Vc1. So should this magnitude be positive or negative? Should it be positive or negative? Negative, right? Because the average voltage across the inductor, it should be 0, right? So this magnitude, actually, what we are writing here, Vs minus Vc1, this magnitude should be negative so that When we integrate over the switching time period, that gives you zero, right? Right?
Yes, sir.
Okay. So now this is your del I2. And then what is the relationship between IL1, IC1 and IS1, IS? So your IS, it should be equals to IL1 and that should be also equals to IC1, right? Because all the elements are in series, right? Now for the second circuit, what should be the voltage across the inductor? VL2, it should be what? Minus
V0.
minus VC2, but we can say it as minus V0, right? So it should be L2 multiplied by del IL2 2 because it's the current 2 in discharge period, and it should be 1 minus D multiplied by TS, that should be equals to minus V0. Or we can write del IL22, that should be equals to minus V0 over L 1 minus D multiplied by TS. So that should be, this should be your equation number 3, and this should be your equation number 4. So now I will sorry. Okay, yeah, L2. So now if I want to do the voltage second balance, voltage second balance for L1, so what we can write? So what was the voltage on N1 during mode 1? It was Vs, right? So we can write Vs multiplied by D into Ts plus what is the voltage across the inductor 1 during the, when the transistor is turned off, it should be Vs minus Vc1 multiplied by 1 minus D into Ts, that should be equals to 0, right? So from here, you can see, you can write Vc1, it should be equals to 1 minus D multiplied by Vs. So that should be your equation number 5. Similarly, if we do the voltage second balance, for L2, what we can get? For L2, what was the voltage across it? Vc1 minus V0. So Vc1 minus V0 multiplied by D into Ts plus what is the voltage across it? Minus V0, right? So minus V0 multiplied by 1 minus D multiplied by Ts, that should give you 0, right? So here, as you can see, from here we can derive your Vc1, that should be equals to V0 over T. That should be your equation number 6. So I will stop this class today here with a simple thing, that since your D, it should be operated between 0 greater than D greater than 1. So as you can see from equation 4, so from equation 4, we can say your Vc1 will be always greater than Vs, and from equation 5, we can say Vc1, it will be also greater than V0. So whatever voltage you have here in the capacitor, here their voltage will be always higher than your input voltage and your output voltage. You got my point, right? So the capacitor, it will always conserve the energy within it. And from your equation 5 and 6, 5 and 6, we can write 1 over 1 minus d multiplied by Vs. It should be equals to V naught over d. So here we can write V naught would be d over 1 minus d multiplied by Vs. So this equation is similar to your buck boost converter, right? Right?
Yes, sir. Yes, sir.
So we'll conclude our class here. If you have any question regarding what we have discussed so far, you can ask me. Otherwise, you are good to go today. ক্লাস কি খুব বেশি মাথার উপর দিয়ে গেছে?
ভাবছি
The second part is hard because you have to deal with two portion of the circuit, right?
yes sir
But if you try to solve by yourself, you will find that it's a very simple circuit. But for the buck and boost converter, we have to deal with only one circuit at a time, right? But here, since we have two inductor and two capacitor, so we have to deal with two inductor at a time with a capacitor. So the equation will be little bit higher. That's why you will feel that it's a clumsy one, but both the operation is pretty much similar. So if you understand the buck boost and the buck boost converter, I think this thing is pretty much easy to understand. So I will let you go today, and I will upload this video tonight, inshallah. So if you have any question, you can ask me. Otherwise, you are free to go today.
Sir, we just syllabus ki sir buck boost converter kon?
Buck boost part, only the theory part will be in the exam, but not the any math related to that one.
Sir, in Friday, you have told that buck boost converter will not be included in the syllabus.
I said theory part will be there, but no math related to buck boost converter. I might ask you a simple
Okay, sir.
explanatory question, but I will not give any mathematics of the design circuit based on the buck boost converter. Okay.
Okay, sir.
So if you don't have any questions,
Assalamu alaikum, sir.
you can go. I will upload the video. You just see that video, and then in the next class, if you have any question, you can ask me. Okay.
Assalamualaikum, sir. Sir, will you please upload the class that you took on your smart notepad?
This thing, the Microsoft Word thing that I just wrote, this thing.
Yes. Today you wrote this, but two classes before
I have
this.
already uploaded everything in the same folder. You just look for it. I have uploaded 4 PDF. So
Alright.
if I upload today's class, it will be 5 PDF in total.
Okay, sir. I will check. Thank you, sir.
Okay, so see you all inshallah on Tuesday, right? You have an exam on that day.
স্যার
Yes.
সো টিউসডে কি আমাদের ক্লাসগুলো হবে থিওরি ক্লাস?
Sorry, I didn't get you.
স্যার আমাদের টিউসডে ক্লাসগুলো কি হবে?
Why not?
স্যার এক্সাম আছে এর জন্য।
Exam will be on the lunch time, right?
Yes, sir.
So why not? I will try to take your class on Thursday also.